Hi, Algebra 2. This is Unit 12, Lesson 2, Sets and Probability. So we have some more vocab in the top here. A set is simply a collection of things, numbers, objects, etc., that satisfy a well-defined criteria. The things that are contained in the set are called the elements of the set. A subset is any set whose elements are all contained within another set. And the complement of a set is the set of elements in the sample space that do not fall into a particular subset. So it's sort of like the opposite. One way that we can show all the elements, or in the set or the sample space, is a Venn diagram. Okay, so this is set S, and set A is a subset, set B is a subset, and where they overlap would be the things that they have in common. But let's look at an example with this. So exercise 1, set A is defined of all collection of all integers that are greater than 0 and less than 10. That's the criteria. Remember, I had to have a well-defined criteria, so there it is right there. I want to write set A out in roster form, so it has to be greater than 0. So that would be 1, 2, 3, but less than 10. I don't have to write these in order, but I'm just writing them in order to make sure I put them all in. All right, but it doesn't have to be in order. So that's set A. Those are all the elements in set A. How would I show set A in a Venn diagram? It would be a very simple Venn diagram. So I just have a circle. I have A, and I would just have to put all those numbers inside the circle. 4, 5, 6, 7, 8, 9. Okay, so they're all there. A subset is any set whose elements are all contained within another set. Give two possible rules that could define subsets of A, and then write the sets as B and C in roster form. Do sets B and C have any elements in common? So how about we do for set B, all elements of A that are even. All elements of A that are even. Okay, and that would mean that I would have 2, 4, 6, and 8. And set C, okay, is going to be all elements, and I'm just making these up, all elements of A that are multiples of 3. So if I go to look at set A, up here, I want to look at the ones that are multiples of 3. Well, that would be 3, 6, 9. And again, I'm going to write that in roster form. Do sets B and C have any elements in common? They sure do. 6 is even, and it's a multiple of 3. So the Venn diagram. Okay, so I have this big box. All right. I have sets B. Okay, so the whole thing is A. B is going to be this circle on the left. C is going to be this circle on the right. So elements that are in B are 2, 4. Now 6 is in both, so I'm going to put 6 in the middle. 8. And then elements that are in C are 3 and 9. And of course 6 is in both, so that's why 6 is in the middle. Now, what are the numbers that are also in A that I haven't listed yet? The 1, the 5, and the 7. So basically, everything in the rectangle are all the elements of A. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. The ones that are in A but are even are in B circle. The ones that are in C that are multiples of 3, that's in C circle, and then the one that is both even and a multiple of 3 is where they overlap. All right, so that's sort of how Venn diagrams work. All right, let's flip this over. Consider an experiment where we first toss a coin and note the outcome, and then roll a 6-sided die and note the outcome. Write a set of ordered pairs, such as did you get a head or a tail on the coin, and what number did you get on the die. So this will be the sample space. So we're going to call this set S. So it's going to need a lot of room here. I can get a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, or a head and a 6. Or I could have gotten a tail and a 1, a tail and a 2, a tail and a 3, a tail and a 4, a tail and a 5, or a tail and a 6. All right, so I have, what do I have? I have 12 possible outcomes. Write a set of ordered pairs that represents the event of getting a tail and an even number. Okay, and I'm going to call that set A. So a tail and a 2 is one possibility, a tail and a 4 is one possibility, and a tail and a 6. So there's 3 possibilities there. The complement of set A will be all of the events in the sample space S that do not fall into set A. So I want to write the complement of set A. So basically, set A is tail and an even number. So that's these guys. The complement of set A is going to be set B. So it's everything but that. So I have to again write all the head possibilities, head in a 1, head in a 2, head in a 3, head in a 4, head in a 5, head in a 6, and then the tails that are not an even number, tail in 1, tail in 3, tail in 5. So the complement is the opposite. All right, what's the probability of A? The probability of A is the number of ways A can happen over the number in the sample space. Well, there are 3 ways A can happen. Those are the ones I have highlighted, and there are 12 numbers in the sample space, so 1/4. The probability of B is the number of ways B can happen over the total number in your sample space. And I'm going to come here and I'm going to count up all the ones in B. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, and again, there's 12 in the sample space is 3/4. Okay, now what's interesting about this is that 1/4 plus 3/4 equals 4/4 or 1. The probability of something happening and the probability of something not happening has to add up to 1, because those are the only 2 possibilities. It either has to happen or not happen. All right, let's look at example 3. Consider rolling a single 6-sided die and recording the result. Let set A be the event of rolling a number greater than 4 and set B be the complement of set A. Draw a Venn diagram that illustrates the sample space S and sets A and B. So my big rectangle, all right, I got my sample space. I got my circle for A, and I got my circle for B, and there's no overlap in them. So for A is a number greater than 4, so that's my 5 and my 6. B is the complement, so that's everything that's not greater than 4. 1, 2, 3, and 4. All right, and there's my Venn diagram. Probability of A is the number of ways A can happen over the number in my sample space, which is 2/6. or 1/3. The probability of B is the number of ways B can happen over the number in my sample space, which is 4/6 or 2/3. What is true about the sum of A and the sum of B? So the probability of A plus the probability of B. Well, 1/3 plus 2/3 is 3/3 or 1. Okay, so what's true? It equals 1. It's guaranteed to happen. It's 100%. The probability of A or the probability of B is 100%. It's guaranteed to happen. You must get either A or B. Those are your only 2 possibilities. Must get either A or B. There's no other choice. Prove that the sum of the probability of an event with the probability of its complement will always be A. The probability of A plus the probability of not A equals the number of ways A can happen over the number in your sample space, the number of ways not A over the number in my sample space. Oops, I was supposed to be adding those up. Okay. And So this is going to be, if I have to add them, probability of A, another way of writing not A is just, I'm going to leave this as not the probability number of ways A, but another way of writing not A is the number in your sample space minus A, and don't worry about this too much, okay? And that will be, notice those A's are going to be canceling out, and you're going to have N, the number of ways in your sample space, over the sample space, which is 1. All right. Answer each of the following problems by using the relationship developed in exercise 3D. So as long as we know the rule, you don't have to prove the rule. If the probability I will draw a red marble from a bag is 3/17, what's the probability I won't draw a red marble from the bag? Well, the probability you won't is 1 minus 3/17. And I'm just going to write 1 as 17/17 is 14/17. All right, so it's always the probability of something happening and not happening adds up to 1. So if you know the probability of something happening, what's the probability of it not happening is 1 minus the probability of it happening. If the probability it will rain tomorrow is 20%, what's the probability that it won't rain? Well, that's 1 minus 0.2, because 20% is just 0.2, is 0.8, or 80%. All right. In theoretical probability calculations, the sets that make up a sample space can get difficult to write out. It's a good thing to remember how to do like a tree diagram to help us. So say I have two 4-sided die that are rolled and the number on each is noted. Draw a tree diagram that represents all the outcomes in the sample space. How many are there? So there's 4 possibilities, 2, 3, 4. The first die I roll, I can get a 1, 2, 3, or 4. Now, if I get a 1 the first time, the second die, I can still get a 1, 2, 3, or 4. If I get a 2 the first time, the second time I can get a 1, 2, 3, or 4. If I get a 3 the first time, the second time I can get a 1, 2, 3, or 4. And if I get a 4 the first time, the second time I can get a 1, 2, 3, or 4. All right? What is the probability that you don't get 2 of the exact same numbers? Well, there's 4, 8, 12, 16. There's 16 possibilities. Okay? The probability that you don't get 2 of the same number. Well, you can just go through and add the ones that are not the same number. So I'm looking for not the same number. So here's not, whoops, I didn't mean to erase that. I meant to highlight that. Not the same, not the same, not the same. The 4 and 4 is the same. Not the same, not the same, not the same. Not the same, not the same, not the same, and not the same, not. So basically 3, 6, 9, 10, 11, 12. So 12/16, which reduces to 3/4, or 75%. Remember, I can write it as a fraction, I can write it as a decimal, I can write it as a percent. All right, given U is 1, 2, 3, 4, 5, 6, 7, 8, and B is 2, 3, 5, 6. Set B is a subset of set U because every element in B is an element in U. What is the complement of B? So basically, cross off the 2, cross off the 3, cross off the 5, and the 6. The complement of the things that are not in B. So that's going to be 1, 4, 7, and 8. So just using some of that vocab. All right, next one, number 7. In a survey of 400 teenage shoppers at a large mall, 240 said they shopped at Abernathy's, 210 said they shopped at Bongo Republic, and 90 said they shopped at both stores. How many of the teenage shoppers surveyed did not shop at either store? All right, so there's 400 total people. I'm going to make like a little Venn diagram to show this whole thing. There's 400 total people, okay? Store A, right here. All right, there's 240 people. I'm going to write this above. You'll see why in a second. Store B, there's 210 people, but there are 90 that shopped at both. So the people that only shopped at A is 240 minus 90 is 150, and the people that only shopped at Bongo Republic is 210 minus 90 is 120. All right, so that's how a Venn diagram can help me out. So again, how did I do that? At A, I did 240 minus 90, is 150. And for B, I did 210 minus 90 is 120. All right. So I want to know how many of the teenagers surveyed did not shop at either store. Well, let's do this. Let's add up the 150, the 90 that shopped at both, and the 120. So there's 360. Again, I'm just adding up these numbers right here. The ones that shopped at A, B, and the ones that shopped at both. Okay? Those all added up to 360 people. They shopped at one or both. There's 400 total, so if I do 400 minus 360, that means there's 40 people that didn't shop at either store. So that one we had to think about a little bit more for sure. All right, last one, but it's already done for us, my little Venn diagram. A survey from the results of 50 students is shown in the diagram. The students were asked whether or not they were taking a foreign language and whether or not they were playing a sport. So 23 people only took a foreign language, 10 people only did a sport, and 14 did both. How many students are taking a foreign language total? Well, that's the 23 plus the 14. So that's 37. How many students play a sport? Well, there's 14 that did a language and a sport, and the 10 only did a sport, but there's 24 total people that play a sport. How many students do both? That's the overlap in the middle. That's 14. How many students do not take a foreign language and do not play a sport? Well, remember, there's 50 students total, so I'm going to put 50 up here. That's my total. All right, so I'm going to do 50 minus 23 minus 14 minus 10. And if you do that in your calculator, 50 minus 23 minus 10, there's 3 people that do not do anything. If a student is randomly chosen from the set, what is the probability that they play a sport but they do not take a foreign language? Well, play a sport, so this is a sport only. There's 10 people out of 50, and that reduces to 1 out of 5. Okay?